So the last section in this chapter looks at polynomial functions with a leading coefficient other than positive or negative 1. So something that could be 5x cubed or 3x to the power of 4. So when we go to factor these leading coefficients, they can be factored in the form of c times these factors. So we kind of did this last year with our quadratic equations. We looked at the quadratic equations with a leading coefficient. That's when we looked at completing the squares. We factored the leading coefficient out as much as possible. So in a sense, that's kind of what we're doing here. We're going to take the leading coefficient out as much as possible. There are two important points for these polynomial functions. Every polynomial function can be written as a product of its factors and the leading coefficient. And every polynomial function has the same number of factors as its degree. The factor might repeat itself, so I might have an x minus a1 squared, but that would then still be 2 factors. The factors could be real, they could be complex, and they can be repeated. So complex means that it's a non-real factor. So in lessons 7 to 9, we looked at polynomial functions where the leading coefficient was a positive or negative 1. This time we look for leading coefficients that could be any real number. So if I look at class example number 1, it's a graph of a third degree polynomial function. The graph has integral x-intercepts. So the word integral implies that the intercepts are integers. So I don't have to look at this and think, is it negative 1 or is it negative 1.2? It's negative 1. It passes through the point of 2 and negative 24. So it says, explain why the equation of the polynomial function can be written in the form of c times x plus 1 times x minus 3. So ignoring the c, where do the factors come from?
The intercepts.
The intercepts. And what are my intercepts?
3, negative 1, and 0.
So they're the zeros, they're the x-intercepts, which then leads me to my factors. So those x-intercepts give me zeros, which then give me factors, which then allow me to factor that equation. And all three of these have a multiplicity of 1. Because all three, the graph goes straight through that intercept. So I can use this point that I was given, this 2 and negative 24, to solve for c. Because if this point is on the graph of the equation, it has to satisfy the equation. It has to make the equation true. So wherever I see an x, I would substitute in a 2. So I would have p of 2 equals c times 2 times 2 plus 1 times 2 minus 3. What is the value of p of 2?
24.
Negative 24. So 2 plus 1 is 3. 2 minus 3 is, so I've got negative 1 times 3 times 2, which is, so negative 6 times c, which means that c would be equal to 4. So then my factored polynomial function would be 4 times x plus 1 times x minus 3. Now, if I expand this, because the question does say write it in expanded form, what I'm going to do is I'm going to start off by multiplying these two binomials. I'm going to multiply them together. So x times x,
X squared.
and then I have the x times negative 3, which is negative 3x. 1 times x is x. So if I take a negative 3x and a positive x together, I would get, and then 1 times negative 3. And then I would multiply that by my 4x. So my final polynomial would be 4x cubed minus 8x squared minus 12x. That's how we deal with leading coefficients. So if I look at class example number 2, the graph represents a polynomial function of the lowest possible degree. The intercepts are integers. Determine the equation of the polynomial function in factored form. So what are my zeros?
-2 and 2.
Okay. So at -2, what would my factor be?
X plus 2.
And if I look at the graph, what is the multiplicity at -2?
3.
3, and it has to be the smallest one, so it's multiplicity 3. I don't have to write 3 or 5 or 7, because the question tells me that it's the lowest possible degree. My 0 of 2 now gives me a factor of x minus 2. And what's the multiplicity?
1.
1. So then my polynomial function p of x is going to start off with that leading coefficient c. I don't know what c is right now, but I'm going to include it in there. And then I have x minus 2 and x plus 2 cubed. Now in order to find the multiplicity, or sorry, not the multiplicity, the leading coefficient, I need to find a point on the graph. And I want to find a point on the graph that I haven't already used. I've already used these 2 points. Is there another point on the graph that I can find?
Y-intercept.
The y-intercept. What is the value of the y-intercept? So what are each of these tick marks worth?
Negative, or 0 or -10.
-10? What do each of these represent? If I take 5 of them to go up to 20, it's 4.
So
-8. So I now have this point that's 0 and -8. So I can substitute that in. Wherever I see an x, I substitute in a 0. And p of x would be -8. So I end up having 2 cubed, which is an 8 times -2. So I have -16c equals -8. So what would c equal? 1/2. So then p of x would now be that leading coefficient of 1/2 times x minus 2 times x plus 2 cubed. So we use the zeros to determine the factors, and we use a point on the graph to find the leading coefficient. So it is a 2-step process. Okay. If we look at class example number 3, it says determine the equation in factored form of a 4th degree polynomial function which passes through the point 1 and -12, and it's tangent to the x-axis at 2 and 0 and -3 and 0. So if you wanted to sketch this, just to give yourself a visual, 2, -3, and then 1 and -12. So in order for this to pass through the point here, and then at some point connect up to -12, it's going to have to go down. And if this is a 4th degree, it means that the left arm's also going to have to do the same thing. So my graph could look something like that. It could look a whole other lots of other ways. But drawing it like that, what does that tell me about my leading coefficient? It's got to be negative. So if I know that before I start solving it, that gives me, when I get that negative number, or if I don't get that negative number, then I want to relook at it. So my 0 of 2 gives me a factor of, and my factor of x of negative 3. So then P of x is the leading coefficient of C, and then I have x plus 3 and x minus 2. If they are tangent, what is the multiplicity? 2. And will the 2 2's give me a 4th degree polynomial? Yes. So now I have my factor form. Then I can substitute in this given point. Wherever I have an x, I can replace it with a 1. And P of x would be equal to negative 12. So 1 plus 3?
4.
And 4 squared? 16. And then 1 minus 2 will be, and when I square negative 1, I get positive 1. So I'm going to have 16c on the right side, negative 12 on the left. Divide both sides by 16, and what would c equal? Negative 3/4. So then P of x equals negative 3/4 times x plus 3 times x minus 2, sorry, got the squares. X plus 3 squared times x minus 2 squared. Okay. There's 2 more examples left that just deal with some real or some rational factors or rational zeros that we have to change into factors. So we'll look at those 2 next, and then you can have all of the questions at the same time. So a 4th degree polynomial function passes to the point 1 and 2, and it has zeros of negative 1, 0, 3/2, and 2. So it says determine the equation in factored form using only integral linear factors. So if I have a 0 at negative 1, what's my factor? If I have a 0 at 0, my factor would be x. We'll skip the 3/2. If I have a 0 at 2, my factor would be, and then that 0 at 3/2. So x equals 3/2. How would I write that as a factor? 2x minus 3. How did you get the 2x minus 3, Hannah? So I multiply first by the 2, and then subtract the 3. So now I have my factors. P of x equals leading coefficient of C. I'll put the x next because it's a monomial. Put the monomials before your binomial factors. And then x plus 1, x minus 2, and 2x minus 3. Then I have that point of 1 and 2. So wherever I see an x, I can substitute in a 1. And P of x would equal 2. So I get 1 plus 1, which is 1. Or sorry, 1 plus 1 is 2. 1 minus 2 is negative 1. 2 times 1 is 2, minus 3 is also negative 1. So 2 equals 2c. And what does c equal? 1. So then P of x would equal, do I have to put 1 in there if it's my leading coefficient? No. So I would just start off with x times x plus 1 times x minus 2 times 2x minus 3. Do my factors have to be in that order? No. Multiplication order doesn't matter, but the x should be out in front. The single factor or the monomial factor should come first. Okay, so I'm going to give you a couple of minutes. I want you to try to do class example number 5. Okay, so let's look at class example number 5. If negative 2 is a root, what's the factor? If 1/3 is a root, what is the factor?
3x minus 1, then it's squared.
And then it's squared because of the multiplicity, good. And if 1 is a root,
X minus 1. And then it's cubed.
good. So my initial polynomial, C for my leading coefficient, x plus 2 times 3x minus 1 squared times x minus 1 cubed. The graph of the corresponding polynomial function has a y-intercept of 2/3. What are the coordinates for this?
0, 2.
So we have 0 plus 2, 3 times 0 minus 1 squared, and 0 minus 1 cubed. So I get 2 times negative 1 squared times negative 1 cubed. I get times negative 2, right? So if I divide by 2 on both sides, I end up with negative 1/3. So then my final polynomial function would be p of x equals negative 1/3 times x plus 2, 3x minus 1 squared, and x minus 1 cubed. So the questions that I have for you, 3 and 5, and then 9 to 14.